Welcome, one and all, to this first talk of the first day of FOSSY 2025. Thank you all very much for coming. Today we will be talking about Subiquity, the server installer for Ubuntu, and starting in 2404, I believe also the desktop installer for Ubuntu. By the end of this talk, every single one of you will be able to install Ubuntu Server, whether that is in a data center, in your lap, in a virtual machine, or on bare metal, with either the world's best, most fine-tuned network infrastructure or with absolutely no infrastructure whatsoever. And you will be able to do it without touching the controls. Now, if you've ever done a Ubuntu server install before, you've seen this screen. This is the interactive manual server installation screen. This is the server installer. It is named Subiquity. Why is it named Subiquity? Canonical thought that it would be a really funny joke for them to name it that because their desktop installer was named Ubiquity, making Subiquity ubiquity for servers. It's a good installer, it gets the job done. But what are you to do if you need to install dozens or hundreds of new machines? Are you supposed to just sit there and wait for each one and dial in the settings by hand? That's miserable, and it's a problem that has long been solved by the community and by the industry as a whole. There are several different tools that you could use to accomplish this, such as fully automatic installation, Kickstart, which has the cutest logo in the talk, or Debian installer for Ubuntu's own upstream, which Canonical used to use. But they weren't quite happy with it, so they made their own and they rolled it into Subiquity, giving you now the control and the power to have extremely predictable, extremely uniform systems from a myriad of different things. Because maybe you're the guy who has to handle 100 different pieces of the puzzle, and automating one little bit of that would really help you quite a bit. Or maybe for people like me and perhaps like you, this kind of thing is just fun and you want to do it. Now, there's a lot of technical detail in this talk. We're going to be covering quite a bit, and I'm going to be showing you a few config files. If you like, you can take pictures of those. You can take pictures of me. I will let you know that all of these slides, along with an extensive write-up, are already available on my website, including some stuff that I couldn't fit into the time slot. So let's lay out a map of what we are going to be talking about today. You're going to get your system booted into the PXE ROM. That is built into your BIOS or your UEFI. Your PXE ROM is then going to talk to your DHCP over the network and retrieve all of the normal information that it needs to retrieve in order to get a network connection up and running. But it's also going to get two extra pieces of information that you don't typically see in a DHCP handshake. The first is a file server address, where the PXE ROM will reach out over TFTP, the Trivial File Transfer Protocol, and retrieve an image to boot. Now, there are various different bootloaders, and I'm not trying to start any flame wars, but I'm going to show you how to do it today using grub. The second parameter that is handed to your PXE ROM by DHCP is the path on the file server for this file. Grub is also going to reach out to your file server, again over TFTP, to grab its configuration and its libraries, and then to grab your initial RAM disk and your kernel. Your kernel is again going to reach out to your file server. This time we've upgraded though. We've come into the late 20th century into HTTP. And it will pull your ISO, which it will boot, and finally give you Subiquity, which, surprise, surprise, is going to reach out to your file server over HTTP again, and get its configs to finally actually build your machine. Now this is a lot to cover in 30 minutes, and in order to keep things light and fun, I have interspersed pictures of my cat throughout the presentation. His name is Max, and here you can see him all tuckered out on the keyboard, enforcing me to take a break from slamming away on the keys. But let's get into it. Let's get you into your PXE ROM. If you are using vSphere, then you want to head on into your VM settings, pop over to the VM options tab, hit the boot options dropdown, and tick this Force BIOS Setup box. This will only be in effect for one boot. On the subsequent reboot, this box will untick itself, but this will, on the next time that you reboot, give you this screen, at which point you want to scroll down to EFI Network and hit Enter. This will PXE boot your virtual machine in vCenter. If you're doing this in libvirt, it could not possibly be easier because all you have to do is add --pixie to your initial virt install command. That'll go out over the network and do what it needs to do after that. I use a lot of Dell hardware in the data center, and if you do as well because they're cheap, then you want to hit F12 during the boot to do a one-time pixie boot, or you can head on into your system setup using any of the other F keys and set pixie to be your default. That's the same with any other server hardware that I've had the opportunity to work with, but there might be something out there that's delete or escape. Who knows? Now, you might be a little bit concerned about setting pixie as your default. You may sit there and think, I'm going to get in a rebuild loop. Every time I reboot the server, it's going to rebuild itself and wipe out everything. But I will show you a way that we can avoid that from happening while still having pixie as your default. Taking a look at our map so far, we've got the pixie ROM booting, and now it's time to set up DHCP to give it the information that it needs. And again, there are already all of these slides on the internet published. You don't need to write them down or take pictures. If you have libvirt's default bridged NAT as part of your libvirt configuration, you will have something that looks extraordinarily similar to this in your XML. And the only thing that we need to do to this in order to get you serving the pixie files to your libvirt clients is add these two lines. The first of which starts up a TFTP daemon inside of libvirt and serves files from that route on the host machine. The second line tells the clients where they should look on that server for the file that they should boot. Now, notably, we are not telling the client which server it should reach out to grab that file. Libvirt actually does that automatically in the background when you start running a TFTP daemon inside of libvirt using this config line right here. If you have more of a real network infrastructure and you're using something like ISC DHCPD like I do, you will need to provide it with that server and the file. Here is a config snippet that will accomplish exactly that. Obviously replace the address with whatever your server address is, but we'll be serving it the grub x64.pixie file. Now maybe you use libvirt, or maybe you use ISC DHCPD. Maybe you would really like to, and you go to your boss and you say, hey, can we use this? And he says, we have DHCPD at home. Actually, you can't use one of those. And most of those are well and good and will get the job done. And there's usually some well-documented and sensibly named option like pixie boot server address or network boot file path that you just need to set. But if you have something really esoteric and you need to get into the nitty-gritty weeds, you want to look at DHCP options 66 and 67 for the server and file respectively. Everyone still good? Cat, all tuckered out yet again, one of his favorite activities. All right, we've got the information being served over DHCP. Now it's time to put the files on the file server that we are going to be serving. And to do that, we're going to need a directory to put things in. I like to put things all in one directory. You could break it out if you like, but I think that this makes things fairly sensible. If you see any relative file paths during this talk, they're underneath this root. And so far, I've shown you that we need to serve the grub x64.pixie file, and you may think, where can I get such a grub x64.pixie file? You could go out to the internet and find one and download it and use it, and it would probably work for you, but it would actually take you longer to go find it than it would take you to just make it yourself. If you've got a standard Ubuntu machine, in order to make these files, all you need to do is install these two packages. Now we're going to create two images here to be network booted instead of just one. This first package will allow us to build an image that can boot on legacy BIOS systems. The second package will allow us to build an image that will boot on modern UEFI systems. Why do we need two? Legacy BIOS systems cannot boot modern UEFI images, and some modern UEFI systems will refuse to boot the legacy BIOS image for some reason. I don't know. We're just going to make two files and use them as needed. Now, the commands to make these two files are relatively straightforward. You only need two commands. These are the two, and let's take a moment here to actually step through the options and see what they're doing. They're both grub make image commands. This -d tells grub make image which directory it should look in on your host file server, in order to find the libraries that it needs to build this binary image that it's building in this command. The -O is the output file format. Here in the first line, we are building 32-bit legacy BIOS, and in the second line, we are building 64-bit UEFI. The -o is just the output file path. You could name it anything you want, but I think that these are some pretty sensible names. -P gives us the prefix for grub. Now, once the grub image starts up, it will need to look for some additional libraries, as well as its own config file. It will look inside of its prefix for those files. And these last two options bundle in the PXE and TFTP, or alternatively the EFI-NET and TFTP libraries into the binary so that we can actually get this binary PXE booted and then reaching out over the network to grab the libraries that it will need. Putting those libraries in place couldn't be easier because they're already present. Hello, welcome in. They're already present on your system. If you installed the packages on the previous slide, all you need to do is run these two commands to make a copy of them that will be accessible over TFTP. You could do a symlink if your TFTP daemon is following symlinks and if the user that it's running as can access those files, but it's a lot simpler to just copy them. So we've done it. We've got grub booting over the network and being able to see its libraries, and then it crashes and gives you an emergency shell because it doesn't have a config file yet. So let's write that config file. Now, this is a very nice and clean and short starter config file that I like to use, and this is what makes it safe to have PXE be your default boot option. What this will do is it will wait 10 seconds and then exit with an error, which will cause the PXE boot ROM to exit with an error, which will cause the system's BIOS to then try the next option, which will be the installed OS on disk. Now, you can just reboot the machine and not have to worry about it getting rebuilt behind your back, because you actually have to sit there and push the up arrow key or the down arrow key to go to a different menu entry, which we will put in there in a little bit. Now that's been a lot of files, so let's take a look at our file tree here. Underneath var PXE, we've got a grub directory with 2 images, a config file, and 2 directories just absolutely chock full of libraries. There's a couple dozen in each one, so I'm not showing you every single file there. This is wonderful. We've got these files on the file server. Now we need a way to actually serve them. Now, PXE booting uses TFTP. That is the standard. That is not an option. That is not a choice that you get to make. That is just what happens. You must use TFTP, and I like to use this package, the TFTPD from HPA. That's just the guy's initials who wrote the thing. But the reason I like this is because it's very small, it's very lightweight, and the configuration is only 4 lines. The first 2 lines are the username that the process should run as and the directory that it should serve files out of. The third line is any additional options you want to pass to the binary. Here we pass --secure. Now, if you've been in this industry for any length of time, you might look at that and say, great, this will be secure. I can maybe make this SSL wrapped or maybe add some authentication. You're wrong. What this --secure does is it makes it so that clients don't need to request the file that they want all the way from the root of the file server. They only need to give the relative path to the TFTP directory. This is more secure because you don't have to expose where on your file server the files are to your clients, who are yourself. It's the default option, so we leave it. And the 4th line in the config is just the address to listen on. Now, this address here, since no interface or IP address is specified, will listen on all interfaces on port number 69. Now, I know what you're thinking. I see that smirk, Romeo, you sly dog. You snuck the funny number into my infrastructure. Ha 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 ha. I didn't sneak the funny number into your infrastructure. Anna snuck the funny number into your infrastructure. 69 is actually the default well-known port for TFTP on TCP and UDP. That wasn't me. It is still funny though. Since we've got our TFTP set up, we might as well take this opportunity to set up our HTTP. Now, again, you could do this in a different file path or on a different server. I like to keep it all on one machine in the same directory tree because it makes things simple. And I'm not trying to start any flame wars here. You can use whichever HTTP daemon that you want, but this is how I do it with Nginx because that's the one that I like. It's very simple, listening on port 80 and just serving files out of there. Now, you could do this on 443 with SSL if you like, if you have a certificate that's valid. But I don't see too much advantage in doing that because we're serving the image that pulls files over this non-encrypted. So what difference does it make if someone's going to inject something in there anyways? Everyone doing good? Cat. Look at those teeth. He's so vicious. He uses them to bite me on the finger while I'm asleep, and I love him so very much. All right, looking at our map here, we've got the PXE-ROM booting, grabbing what it needs over DHCP, grabbing grub over the file server. Grub's able to get everything that it needs. Now it's time to give it the initial RAM disk and the kernel to pull. Canonical once claimed that they would publish the initial RAM disk and the kernel as separate files so that you don't have to fish them out of the ISO. I have never been able to find those files published separately, so you have to fish them out of the ISO. You go download the ISO, don't let them lie to you. It's not 3 gigabytes, it's 3 gigabytes, they're different. And then, once you've got that ISO downloaded, you mount it to your local file system, and all you need to do is copy out the two files, VM linas for your kernel and initrd for your initial RAM disk. These are special, magical ones made by Canonical that will actually be able to do what we need to get done later on. If you pull these out of any other distribution or build them yourself, you're not going to have a great time. Just pull them out of the ISO. I keep these as files in the Casper directory because that's where they started, and I think that if I modify less things, I have less room for problems to crop up in the future. Maybe I'm crazy, or maybe I can sleep at night and not have to stare at the rectangle more. Now that we've got the initial RAM disk getting pulled over the network and booting, it needs to reach out and grab the ISO, because the initial RAM disk by itself doesn't have everything that's needed to build your machine. So we need to make that ISO available. It's a good thing that we downloaded it. It's going to get downloaded, and it's going from your file server to your machine that's being built. And it's going to be mounted on your RAM disk, and it's 3 gigabytes. And you might look at that and say, that's no problem. I have 256 gigabytes of RAM. That's no issue. I can handle that. But what if you want to do it on a 2 gig machine or a 512 meg machine? What if you want to auto build Raspberry Pis? Can I get maybe a netboot ISO like what used to exist when they used Debian installer? Canonical says no, you can't do that because the installer requires a more full-featured root file system. 3 gigabytes is the lowest that they can go, according to Canonical. According to the Ubuntu team, they can fit everything, including a minimized desktop environment, into 2.6, so maybe there's some cruft that could be pulled out and make it a little bit smaller, but I don't work for Canonical, so who knows. Let's take a look at our file tree again, because we've added some stuff to it. We've got the Casper directory with the RAM disk and the kernel, and we've got the ISOs directory with the ISO that we have. I'm not showing you what's in grub because you've already seen it. Now it's time to modify our main grub config file to actually let it pull these files over the network and get things rolling. This is a menu entry for grub, which is representative of what all of your auto build entries are going to look like. Everything that we care about gets passed on the kernel command line, not because it gets used by the kernel, but because that information is accessible to every single process that runs. Everybody can just cat proc cmd _ line, I think, and see what's in there. So this is the information, this is where we pass information actually to the RAM disk and actually to Subiquity, but we put it on the kernel command line. Now, this is almost exactly what every single one of your menu entries for auto building is going to look like. The only differences from one to another are first this URL parameter, which is the URL to the ISO. When 2604 comes out, you'll want to make some new menu entries for that. If you want to build old 22 or 2004 entries, or anything in between, then you need to download the ISO and make that change in grub. The next one is this s equals parameter. S here stands for seed from, not source. You could write seed from if you want, but it takes up more space on the slide. And this is the path on the network where Subiquity will look for the config files. These are the config files that Subiquity will use to actually build your final server. These two red pieces of text here are the only thing that will really change from one menu entry to the other. And also the ID, because otherwise Grub will complain. Everyone doing pretty good? Cat, in a box. Look at him, he's so cute. All right, we've got everything coming on over the network now. We've got a bare metal or virtual server, pulling everything that it needs. Nothing had to be on disk already, and we've got Subiquity running and getting its configs. Let's put those configs in place, shall we? You write those configs for Subiquity. You write them in YAML. Subiquity takes your YAML configs, and it takes YAML configs from a few other places that Canonical wrote tools to provide YAML configs, and it generates a curtain config in the background that you don't get to see. The curtain config is also YAML. Curtain then actually does the heavy lifting and the hard work of partitioning your disks, installing packages, and putting your final system configs in place, which in many cases are also YAML. And sometimes I feel like I'm going crazy because it's always YAML. You look under the hood from where there was YAML and there's more YAML. And it's YAML all the way down. And when I go to sleep and I close my eyes, guess what? There's YAML. But let's take a look at that YAML, shall we? There are two important config files for Subiquity that we need to care about. The first is metadata, which contains one line of text. This is it. That red line there is all you need in that file. You can put any string you want for the instance ID. The documentation says that it should be codename-auto install, so noble-auto install for 2404, but that's not enforced. You can actually have it be anything that you want. I like to have a little bit of fun in that string. It doesn't show up anywhere, but it makes me smile on the inside. It can't be empty though. This file does need to exist, and this line does need to be in it, and the string does need to be a string. Otherwise, Subiquity will crash and you'll have a error on your hands. The second file that Subiquity looks at is user-data, and this is where all of the meat and potatoes goes for your auto build. Now, this file can be quite long. On many of my builds, it is about this long. The minimum viable version of this file is still too long for me to go into great detail during my 30-minute slot here. So I'm only going to give you the most important bits and the bits that have information that you have a really hard time finding online. First, packages. You need to install a package. I use it to install packages for my config management before I get the server booted up for the first time. Really handy. But what do you do if the package you want isn't in the stock default Canonical repositories like Salt Minion isn't? Well, you got to put the repository in there, which Subiquity can handle. It looks a little bit like that. It goes into the apt section, obviously replace the URL with the real one that's too long to fit on my slide. And you can do this for as many different repositories as you like, just different sources, subsections. Now, you do need to provide it with a GPG key, because otherwise apt will give you an error, and then Subiquity will see that error, and then Subiquity will crash, and you'll just be standing there looking at an error message, being like, So we give it a key ID. Subiquity will go out to Canonical's key server, pull the key that matches that ID, and use that in its place, or use that for this repository. Now, there are many places in the documentation for Subiquity, for Curtain, and for Cloud Init, as well as in official and community examples where you provide the whole entire text of the GPG key instead of just the key ID. Then you don't have to rely on it being on the key server. However, this broke about a month ago and it hasn't been fixed yet, so use the key ID for now. Our next section to look at here is the storage section, and this is the bit that makes my Subiquity configs miles and miles long. What we have here is the minimum viable size for the storage section of the config. And what this minimum viable configuration will do is it will look at your server and it will find the largest disk that it can find, and it will install Ubuntu onto that with one gigantic root partition under LVM formatted ext4 for everything. That's probably not what you want for production equipment. That's not what I want for production equipment, because then var log fills up and everything explodes. You could sit there and read through the documentation and pore through things for days and days and try to actually fine-tune your own storage section. But I wouldn't recommend that because it's a huge time sink, and instead you can just do it manually one time. When you manually do it one time, Subiquity on the manually built server will generate this file, the auto install user data, which will contain the user data file that you would have needed had you wanted to accomplish everything automatically without having to do any manual intervention. This is great because it gives you all of the storage configuration that you configured manually in Subiquity, but in a way that you can automate, which is exactly what we want. I will give you a little bit of a heads up here. There is a different disk layout required for legacy BIOS and modern UEFI because they boot differently. Canonical doesn't tell you that anywhere in the documentation. You just have to figure it out, but generate 2 of these and you're good to go. The next section that is incredibly important for you to know about is the early commands section. Now, this is a YAML list of commands that will run before Subiquity does anything else on your machine. And what these 2 commands do is they change the password of the installer and the Ubuntu Server users to PW. Could be anything, just as long as it's something that you know. Because by default, when Subiquity starts, it sets these 2 passwords to random strings, which isn't useful, but if you know what the password is, then you can SSH into the machine while it's being built. If you SSH in as the installer user, you just get to watch TTY1, which allows you to monitor Subiquity's build process, and when it crashes and gives you an error message, you can debug and troubleshoot it right there from your terminal, from your desk, and not from the cold data center where no food and drinks are allowed. You can do it from your desk and have a little snack and a cup of tea. And you can have your cat. The second user here doesn't monitor TTY1. You just get dumped straight into a shell, so you don't have to wait for things to fail before you can get a root shell. Wonderful user accounts. I really like them. They're not documented anywhere. You just have to figure them out. Our next section to look at is the identity section. This is where you set your name, your username, and your password. Now, documentation and common sense say that that password should be hashed. Here's the command to generate the hashed password. It's not in the Subiquity documentation. I don't know why. It's 1 line and it's short, but there it is. It's also where you set the host name for your machine. Now, it's probably not super useful for you to have all of your auto-built machines have the same host name. It's not super useful for me to do that. There used to be a secret undocumented feature where if you just set this to localhost, it would then pull the host name over DHCP every time it boots. But they took that away. And then I went and I rebuilt a whole cluster at my work and wound up with 24 brand new shiny localhost. So now you need to do your dynamic host name setting as a big long bash one-liner in late commands. This is the opposite of early commands. These run after Subiquity has done anything else. This is also where I drop some default config files for my configuration management suite. I'll give you a heads up though, if you put things under the root directory in this stage, they will be wiped out because that is your ephemeral RAM disk mounted ISO that will explode into a million pieces. I don't know what happens to RAM when you reboot your computer. It goes to 0. If you want it to actually be available on your final system, you need to put your files in /target. That's not documented anywhere. You just have to figure it out. You may have noticed a trend. Now, those are the most important sections of the Subiquity config. The rest of it is pretty standard, self-explanatory, and I have an example on my website already published alongside these slides and a write-up, so you're good to go there. Let's take a look at our file tree again. We've got a bunch of directories you've already seen, but in this new conf directory, we have our metadata and our user data files. Cat. He's so smart, he knows which box he's supposed to go in. He can read English. All right, looking at our map, we've rounded all the bases, we've ticked all the boxes, we've got it going, everybody. Congratulations. We've got Subiquity booting over the network. You didn't have to have anything on disk to start with. It pulls its config files, it builds your server, everything is great, except sometimes it's not. Sometimes it crashes and you're sitting there saying, why did it crash? Well, it's YAML, so it's probably one of 2 reasons. Reason number 1, you forgot to put a colon. Reason number 2, you did a tab character. Naughty, naughty, that's forbidden in YAML. Go fix it and try again. If it's not one of those 2 reasons, then it's something else, and you can troubleshoot it on the system that failed building because you're dropped into an emergency shell when Subiquity crashes. It is a little bit of an intimidating emergency shell because it looks like that, and it doesn't get any less intimidating when you realize that that is the command that ran and failed and caused Subiquity to crash. But if you actually sit there and take the time to read through that command left to right, top to bottom, like how English is, you'll find that it's a systemd wrapper that sets a bunch of environment variables and uses an absolute path that's not necessary in your emergency shell, and you can reconstruct the command to this relatively straightforward Python wrapper for apt-get update. And you can run it by hand, and you can see the error message, and you can see the problem, right? There's no problem, actually. It ran fine when we did it by hand, but here it spat out an error and caused our build to crash. So that means we're going to have to dig a little deeper in the crash logs. These are also a little bit intimidating because they start with all of D message, and then they end with that. But you're in a pager at least, so you can search for the command that failed, and you'll find it as long as you type it right. And then you scroll down just a little bit in your pager to see the standard output and the standard error, and we see that it failed because the expected and actual file size of the package list were different. An apt will even speculate for us and say, maybe there's a mirror sync in progress. This is, for years, something that I never once saw happen, but over the last couple of months, it has been happening more and more and more frequently, and it always seems to happen while downloading and installing security updates. One of the final things that Subiquity does, not quite the last, though. Now you may sit there and think, can I disable these updates? Because they're error prone, they're unstable, and they take a really long time. And I could do them in parallel later when my config management is running and get my server in production faster, and that would be good, right? Can I please disable these updates? Well, Canonical says no, because why would you want to? So without any ability to disable these updates or just a simple retry command to restart Subiquity from the top, you're stuck every time you see this for the third time today before lunch, rebooting your machine and waiting for your 15-year-old Dell hardware to reinitialize itself and then fail again. Please, if anyone from Canonical ever sees this, just give me a retry button. Just give me one command I can use to restart Subiquity from the top. This would also let me fix my bad boy mistakes in YAML, because the generated YAML is just a file in the RAM disk, and this would save me so much time. This button, if it existed, would have saved me dozens of hours over the last 4 years. All right, we're nearing the end of our time here, and I did promise you would be able to do all of this without a network connection. And that's true, you can, but I don't have enough time to show you exactly how, so I'm going to give you the SparkNotes version. You download the ISO, just the standard Ubuntu Server ISO, and you 7-zip it on open, or use whichever program you want. Then you put your Subiquity and grub config files into there where they need to go. It's a slightly different version of the grub config file than what I showed you already, but it's pretty similar. Also, did you know that grub had a logo? I love it. It's so cool. Next, you update the checksums in md5sum.txt, which is a file inside of the ISO root, because if you don't do that, then the ISO will start up and then say, ah, and explode into a million little pieces. And then you run a super long XOR ISO command. It's about this long, and it has a whole bunch of just like checksums in the command. But you run it and you get your auto build ISO spat out. You then boot that off of a thumb drive or CD or DVD, and you can build machines in the woods with no network connection whatsoever. The commands and the notes on how to do all of this in great detail are available right now on my website, puncto.org. That is my email address. I am root@puncto.org. In real life, my name is Romeo, and that is kind of what I look like. For the past 10 years or so, I have been, in one form or another, job title or another, a professional Linux user. For the last 4 of those years, I have been a Subiquity wrangler. I would like to give a big thanks to the Software Freedom Conservancy for putting on this lovely event and giving me a platform to talk. And I would also like to give a huge thanks to Canonical for writing Subiquity, because despite all of my complaining about it, I whine about their tools the way that a Subaru mechanic whines about head gaskets. I'd like to give a huge thanks to my cat, Max, for being so cuddly and cute and improving the slides. And if we have time, does anybody have any questions?
There is Subiquity, and there is something called auto install, and there is something called cloud init, and I think they're all kind of the same thing. And then there's also Kickstart, which I think is a different thing. Do you know the connections between these terms at all?
Yeah, so the question is, what is the connection between Subiquity, Cloud Init, and auto install and Kickstart? Kickstart is a completely different project that's for, I think it was originally for cent-based stuff. I don't know that it supports Ubuntu. Now, Cloud Init is something that Canonical started working on so that cloud service providers could auto-deploy Ubuntu VMs. I think they started on that in 2012. And there's a lot of configuration from that that's been pulled over into the Subiquity auto installer. And it still gets used a little bit on the first boot after an auto install is done. It does some Cloud Init stuff. The Subiquity is just the server installer for Ubuntu. And then the auto install is the term for the auto install functionality of Subiquity. There is also Curtain in the background, which Subiquity feeds into and has kind of a superset of its functionality, but sometimes it translates stuff differently, and sometimes Curtain will act differently if it's been fed this information from Subiquity or if it gets it from somewhere else. It's super intuitive, and it's really well documented. But yeah, there's a little bit of a mess in terms of where do you look for documentation or what exactly is the part that's broken. I do have on my big write-up of this topic on my site, there is links to the most important pieces of documentation that I normally look at when something goes funky. Does that help answer your question? All right. Anybody else? All right. Well, thank you very much for coming to my talk. I hope you had a good time.